What's the domain here? X greater than what? Yep. If I graph it, right? If I graph it, which you should, so y equals the ln of 2x minus 3, right? Look at the domain is easy to see, right? You can see a vertical asymptote of x equals 0, right? Yes? What else does it want me to do here in the book? Sorry. It says find the domain, get the inverse, graph them, and then get the range of the inverse, right? So anyway, do you see the range here? Do you see the range of f? How far down does it go? Look at the function. How far down does it go? Forever, right? So I'm wondering if there's some kind of horizontal asymptote that stops it from climbing up higher. And oftentimes it's easier to think of the inverse function. So this is a question mark. I don't quite know if I get the range from this graph. Guys, will you please? I'm not quite sure if I get the range from this graph. Doesn't it look like it's not going to go higher than a certain number? Yeah, it's not 1. And I can do a quick check, y equals 1, right? So it's definitely not 1. But it's right, it's under 20, yes? Well, let's see what happens if we find the inverse function. So how do I find this inverse function? So y equals ln of 2x minus 3. What do I want to do? I want to isolate my log, right? So y plus 3 equals the ln of 2x. What's my base? E. What's the exponent? Y plus 3 equals 2x. I'm solving for x. So e to the y plus 3 all over 2. And I switch my x and y. And that's my inverse. G of x is f inverse of x, which is e to the x plus 3 over 2. So let's graph it. Yeah, one second. E raised to the x plus 3. Oops. All divided by 2. Right, what are we doing here? We're finding the inverse, right? What's the domain here? What's the domain of G? Yep. Well, what's the domain of e to the x? Everything, right? So if I then shift it 3 to the left, what's the domain? Everything. And then if I divide everything by 2, I still get everything, right? So the domain here is all reals, which means my range here is what? The domain of the inverse is the range of the original. So this thing does not get cut off. This green graph goes up and up and up forever, but really, really slowly. Really slowly. It takes forever to get there. Nice. Let's do the last one here. And then we can move on. This is 5.4, number 93. No, 89 I said. And I've got log base 3 of x equals 2. I want to solve for x. I don't know what to do, so the first thing on my list is my translation. What's the base? What's the exponent? 2. What's the argument? X. So what's x equal? Question? Argument is what I put into the function. So sine, like a sine function, the argument we use theta. So argument is just what I'm putting in the function. All right, cool. Let's go over our properties. So this is 5.5. Properties of logs. And I told you these problems seem stupid, and they seem like, what the hell is going on? That's what I remember saying to myself when I learned this stuff. What the hell? And you got to kind of be okay with. You have to kind of. It's like in life when you kind of accept something. Like, you got to accept traffic. If you live in this area, you have to accept traffic. There's no way around it, okay? Right? So, and then you learn to deal with it. So it's going to be the same way. You have to accept these properties and then learn to deal with it. But you driving in traffic, you got to learn how to deal with it, right? So you might get an offender bender. Someone might give you the finger, whatever, right? But you got to deal with it. You got to practice. You got to make mistakes, and you'll get better. So our properties of logs, we have a whole bunch of them. Let's see. We had special bases, right? Log base 10 of x is better written as log of x. And because we're 10-fingered people, or at least most of us. And log base e of x, we call that the ln of x. The natural log, and there's a reason for it, but I don't want to talk about it now. We got our translation. If I give you e to the x equals y, that's equivalent to, b to the x, right? That's equivalent to log base b of y is x. And so all I'm saying there, notice the answer to a log problem is an exponent, right? The answer to the log problem is an exponent, yes? We've got our exponential properties. I don't care about the names, okay? We know that the log of a times b is log of a plus log of b. The log of a divided by b is log of a minus log of b. Yep. No, what? Oh, thank you. Thank you. The log of a to the n is n times the log of a. So I like that translation of that last one as if the log of your argument has an exponent. If the argument has an exponent, that exponent comes out as a coefficient. We have inverse properties. That is log base b of b to the x is x. When I compose inverses together, I get x. Right? When I compose a function with its inverse, everything falls away and I just get x left. So same thing, b to the log base b of x is also x. When I compose a function, a log function base b with an exponential function base b, everything falls away. Okay? I still remember my one pre-cal teacher teaching it like this. The ln of e to the junk is junk. And e to the ln of junk, I guess junk has a different meaning these days, but, right? Whatever the argument is, if I compose a log with its inverse or an exponential with its inverse, I get just whatever the argument is. I need a change of base formula. So when you're practicing this stuff, you've got these formulas out. You should be working on your formula sheet, right? So hopefully you're just looking at your formula sheet, not your whole notebook. So you're going to get the things down on that formula sheet that you need. You should be running out of room soon. You will definitely run out of room when we start doing chapters 6 and 7. So change of base formula. The log base b of a is log of a over log of b, or ln of a over ln of b. We can do we can just show that's true now. I can prove it to you if you want, but I can just show right, I can show any of these. Let me show a couple of them at least. Let me show an inverse property first. So ln of e to the fifth. It's 5. ln and e are inverse functions, right? 10 to the log of 7. Sorry. 10 raised to the log of 7. Seven. 10 to the x is the exponential function. Log is log base 10 of x. So when I raise, right, a base 10 function to a log function, they undo each other, and I get just the argument. I get back to the beginning. Change of base. So let's do log base 3 of 9, right? We know the answer is 2. If you can start thinking in terms of logs, right? I'm thinking, okay, the base is 3. What exponent do I need to get to 9, right? That's what I'm thinking. right? But I want to show that that's equal to the ln of 9 divided by the ln of 3. So the ln of the argument over the ln of the base, also 2. So log of 9 divided by log of 3, also 2. So change of base formula. Weird. You got to get to work on them, okay? So here we go. Let's look at some problems from 5.5. The most difficult piece is 5.6, and it's the most important, okay? So we're almost ready to start working on it. Okay, so we're just going to pick a couple of problems here. Look at 13. Log base 3 of the argument 3 to the 71st power. What happens? What happens? The base is 3. So if you don't know the answer, we could call it x, right? And then I could translate, but this is easier than that. Log base 3 and 3 to the x are inverse functions. So what should I get as the answer? 71. Let's translate it though. What's my base? What's the exponent? X, right? The answer to a log function is an exponent. What's the argument? 3 to the 71. So what does x equal? Duh. 71. It's obvious, right? I didn't need to do that. I can just use my new properties. If I'm composing inverse functions, everything falls away except for the argument. Log base 3 and 3 to the x, right? Log base 3 of x and 3 to the x are inverses. So log base 3 of 3 to the junk is just junk. Let's do another one. This is 25. I know I'm going to run out of battery here in a second. I'm at 7%. Don't you hate that feeling? I left it home. The other day I left my whole phone at home. I was freaking out. Yeah. This is 5.5, number 25. I've got 3 to the log base 3 of 5 minus log base 3 of 4. All of that is in my exponent. Do you see any properties I can do? Can I do anything with a log base 3 minus another log base 3? The answer is yes. I can combine them into log base 3 of a division, right? When I'm dividing like bases, I subtract exponents. Now what happens? Well, 3 to the x and log base 3 of x are inverses. So what do they do to each other? Cancel. So what do I get? 5 over 4. Whatever is in there. Whatever argument is in there. 3 to the x and log base 3 of x cancel out. It's weird. But accept. Do. Move on. Okay? If you get things wrong, ask for help. You can send me a problem. I'll answer. Let's do another one. 45. Now, I didn't assign any of these to turn in because I just want you to do them all because they're easy, okay? So it's going to ask you to use the properties to expand or contract a log expression. So in 45, I want you to expand log base A of u squared v cubed. Well, I'm multiplying something in my log function, right? The argument is a product. So I know I can split that into a sum. So log base A of u squared plus log base A of v cubed. And my arguments have exponents on them, and I know those exponents can come down as a multiplier. So final answer is 2 times log base A of u plus 3 times log base A of v. Weird. But get used to it. I need these properties. I need to practice these properties so I can do the very next section, which is solving log equations or exponential equations. How are we doing? We okay? It's weird, right? Anybody agree? It's like, what the hell am I doing? Right? And that feeling happens several times in pre-calculus. What the hell are we doing? And you'll see it come into play right in the very next section, okay? And then you might say, well, what the hell is the point? And you already know there's nothing has a point in life. If you don't know that yet, learn it soon but then you find something that you can dedicate yourself to in life, right? Even though it's pointless. But maybe you build a building someday, or you design an engine, or you do heart surgery, right? So along the way, it's just a game. Let's do 61. So on this one, they want me to contract. So take a big old expression and make it into a nice simple one, right? So this is 5.5, number 61. I've got log base 4 of x squared minus 1 minus 5 times log base 4 of x plus 1. So first of all, I have to kind of do my properties in inverse order. I don't want to combine this yet because I want just 2 log functions before I can combine them. So I want to move that 5. Where can I move the 5? Where can I move this 5? It becomes what? Yes. Yes. I probably should prove that one to you. That one's, right? I didn't prove that one. I proved the first property, right? Now I can combine this to a single log base 4 of x squared minus 1 over x plus 1 to the 5th. And I look at the answer and it's not the same. So I realize that I probably can factor here. X squared minus 1 is x plus 1 times x minus 1 over x plus 1 to the 4th times one more x plus 1, right? There's an x plus 1 to the 5th. Yes? So there it is, log base 4 of x minus 1 over x plus 1 to the 4th. Cool. So there's lots of problems there for you to do, right? What did I say for that section? Yeah, I like 1 to 81, right? So you're doing as many problems as you can, odds from 1 to 81, right? I don't care where you write them. I don't want you doing them mentally. Get some paper. You have to use paper and pencil or whatever you like to write with. Okay? And do them. They shouldn't take long. And hopefully you'll start to see patterns and get used to it a little bit. Rafi, good? Yep. You have to be doing work. You can't just come to class. You have to practice. We meet 5 hours a week. That means I want 10 to 15 hours a week outside of class. All right, here we go. 5, 6. Chris, yes? Almost? Oh, wait. Oh, wait. Yeah. Good. So solving log and expo equations. So let's see, what do we know? 2 squared is what, 4? And 2 cubed is 8, right? So what the hell gets me to 5? What exponent gets me to 5? Obviously between what? Between what two numbers? 2 and 3. Closer to 2. So this is the essence. If you can solve this problem, you can solve any problem in this section. Okay? So this is the only one I have to teach, and then we're just going for it. We're going to do problems. So the idea is, right, if 2 to the x is 5, solve for x. My preference is to take the ln of both sides. Why am I allowed to do that? What kind of function is 2 to the x? What kind of function is 2 to the x? Exponential function, yes. What else? What kind of function is 2 to the x? Hello? Anybody there? What? Nope. Say again? Yes, but we knew that. Right? We all knew that. Yes, I hope. 2 to the x. Where's the variable? Is the exponent, right? That's exponential. What other properties? We just learned about this. 1-to-1. It's a 1-to-1 function. What does that mean? If I take a 1-to-1 function and it's equal, right? So if I take a 1-to-1 piece and put it into one-to-one piece, or take a 1-to-1 function and wrap it around equal, I keep equal. So ln of both sides is still equal because they're 1-to-1. Right? Remember what I said? If f of a equals f of b, then a has to equal b. Right? The same way, if a equals b, then f of a had better equal f of b if it's 1-to-1. So what happens here? What kind of property? What can I do? What property can I use? You see my argument has an exponent on it? Yep, so that argument comes out as an x, as a coefficient. So I've got the x times the ln of 2 equals the ln of 5. Remember, I'm solving for x, so I'm going to divide by what number? Ln of 2. Ln of 2 is a number, right? This is my exact answer. And then I can go change a base. I can do anything else I want here to get an approximate. So let me just get an approximate answer here. Ln of 5 over ln of 2, right? So 2.32. I want all exact answers. I can use a change of base formula. So I know this is also log of 5 over log of 2. And I also know it's what? Log base what? It's log base 2 of 5. So my change of base formula is log base b of a is ln of a over ln of b, or log of a over log of b. I personally prefer to take the ln of both sides whenever I can. But it won't matter. I can do anything I want. I can do the same problem again, but I'm going to do it with log base 2 this time. So log base 2 of 2 to the x is equal to log base 2 of 5. What happens on the left? What happens on the left? Say again? Yeah, so they're inverses, right? Oh, right here. I'm solving 2 to the x is 5 again. I took the log base 2 of both sides. Why did I choose log base 2? Because I have base 2 as my exponential. What happens to log base 2 and 2 to the log base 2 of x and 2 to the x? What do they do to each other? They cancel each other out. They're inverse functions. So what do I get on the left? What do I get on the left? It's easy. X. Done. I personally prefer to use ln all the time, because ln is 2 letters and log base 2 is way too many. Right? 2 characters for ln, 4 characters for log base 2. All right, let's do some problems from 5.5. All right, we're done with chapter 5. I'm sorry, it's 5.6. The one I always like is something like number 51. Oh, no, let's do number 50. Ivan, will you shut that door for me, please? The talking is driving me a little bit crazy. I know you're all worried about the quiz, but if you're talking to someone next to you, Sina, please. If you're talking to someone next to you and I'm teaching something else, you're missing that. So during class time, control me. You are paying me. Don't talk over me, please. I understand you could be nervous about something. If you're really so nervous about it that you're willing to miss the next topic, not brilliant. But go outside and talk about it. Work on a problem outside. Or ask me to do it. You're paying me to teach you this damn stuff. All right, this is so I'm just picking the most difficult problem from this section. 5.6, number 50. I think I assigned you 51. No, 49, right? So 5.6, number 50. I want to solve for x. 2 to the x plus 1 equals 5 to the 1 minus 2x. What logs do you see that I could use that would work here? What log functions do you see that I could use? Log base 2, log base 5, log base 10, or ln? I'm going to choose ln. I always choose ln. So I'm taking the ln of both sides. Why am I allowed to do that? Because the functions I have presently, 2 to the x and 5 to the x, are 1 to 1. So I know there's only one place that they're matching up. What happens to my exponents? They come back outside as a coefficient. And you got to be careful with multi-terms, right? You got to make sure you wrap them, not in like a M&M sense, but, you know, with parentheses. Yes, you with me? Remember what I'm doing, and this should start to feel like something we've already done. This should start to feel like finding that inverse function. I'm going to distribute, right? So I have x ln of 2 plus ln of 2 equals ln of 5 minus 2x ln of 5. Right? I'm distributing there. Everybody okay there? What am I solving for? X. I want all of my x terms on one side with the minimum number of negatives. So I'm going to move my x terms to the left and my non-x terms to the right. Everybody with me there? ln of 2 is on the left, it's positive. I move it to the right, it becomes negative, right? Negative 2x ln of 5 is negative. If I move it to the left, it becomes positive 2x ln of 5, right? Begins with an F, ends with a Sidney Poitier. Begins with an F, ends with a Tom Cruise. Begins with an F, ends with an actor. Thank you. Factor out the x. X times the ln of 2 plus 2 ln of 5. It looks like I can apply a property, two properties on the left and one property on the right. Did we lock someone out? Chris? Sorry, Chris. Were you out there long? Good. So what does this one become? I got the ln of 2 plus what? Ln of what? Nope. Nope. Ln of 2 plus ln of what? Five squared, right? That 2, that's a coefficient, becomes the exponent of the argument. So ln of 25 equals ln of what? What property do you see there? I'm subtracting 2 logs. So what do I do with the arguments? Divide. So I've got x times the ln of what? I'm adding 2 logs. What do I do with the arguments? Multiply. Ln of 50. So x equals the ln of 5 halves over the ln of 50. There's my nice exact answer. Yep.
Okay, so you got ln, you got ln2 plus 2 ln plus 5.
Yeah.
So then it's 10 to 25?
Yep, because it becomes the exponent of the argument, 5 squared. These properties are weird. You gotta jump in there, try and use them. This is a decent exact answer. I can write it as a single log with what base? Yes, log base 50 of 5 halves. Again, that's an even better exact answer. And of course, I can get an approximate answer. And I always want exact answers, okay? Always. You can also give me approximate answers, right? CD, just prop that door open so you can get back in, okay? So change of base formula here, yes? I'm going to use this version, ln of 5 halves over ln of 50. Yep. ln of 5 halves, oops. Was that 2.5 over ln of 50? So 0.234. All right, you got lots to work on. Get to work. Please, you've got to be giving me 10 plus hours outside of class. If you're at home and you're getting stuck, not going to be good, right? So practice at school, practice in the Math Learning Center, practice with your study group, go to the virtual hours in the Math Learning Center, come to office hours before class, every class, from 12:30 to 2. I'm waiting to help you. If you all took advantage of my office hours, I would go nuts, but I want you to. You have to be asking for help if you're stuck. All right, let's take a little break, then we'll take a quiz. We'll start the quiz at about 4 or 5 minutes. If you need a break, go for it.